What I'd like to do is just simply introduce John Menerick speaking about open source fairy dust and poking holes and all sorts of weird crap. So, take care, sir.
Good morning, everyone. Would anyone like some bubbly? Come on up. Come on. Anyone right here?
Yes, I need alcohol.
So I just asked that individual for, hey, can I see your driver's license? Like, oh, dude, I'm gonna steal his identity. He's like, fuck you. And I'm like, damn it. So yes, cheers to Sec Barbie and Z Faisal. Thank you very much for the lovely champagne. And yeah, this talk will be quite interesting. We're going to talk about open source projects, particularly the ones that allow the internet to run, or vice versa, the internet runs on them. It'll be quite interesting. And overall in my day-to-day life, or in real life, I am a security dragon at NetSuite. Do fun things, good or bad, depending on your point of view. And let's get the legal part out of the way. The views and opinions expressed here are my own, only and in no way represent the views, positions, or opinions, expression or implied, of my employer, present or past, or of anyone else of my thoughts and opinions. They also like to change from time to time. This is a natural offshoot of having an open, inquisitive mind. So let's start off with what we're not going to be talking about. We're not going to be talking about the flame wars between proprietary or closed source versus open source. That's been beaten to death and will continue on forevermore. We're not going to be talking about, how should I put it, the scariest exploits and vulnerabilities in many of these projects, because personally I like having a big toolbox that I can pull from to pull these out. So I'm not going to be dropping the latest and greatest here. And also I haven't told anyone, so like, hey guys, here's this awesome remote code exploit for Linux or for Bind or for NTP. Yeah, I don't think a lot of people will be very happy with me, including US CERT and other certs around the world. But I know I'd make a lot of underground people happy. So what we're going to talk about is this magical fairyland with unicorns and pixies and fairy dust. And that's what I thought the internet was mostly of. LOL cats, ceiling, cat, always looking down on you, and everything was magical and fun. And then one day I was looking at Node.js from a security application perspective. Are they checking validation, things like that? And then I was like, oh my God, this is scary. Where's the bleach? I need it for my eyes. Like, what's going on? And I just took that further. I looked at Bind, I looked at NTP, I looked at web servers. I just went on and on. I'm like, this is really bad. And then I started looking at, is this a systemic issue? I mean, really, what's going on here? Because when I look at the CVE numbers, there's not many out there. So it's like, what's going on? So we're going to start off with a very simple welcome to open source. Welcome to the internet. Here's some of the data that I found. Drop some O-days and whatnot, and then show you guys how to reproduce this and test it all on your own. So we'll have our lovely assistant Jen here show us the internet. Yes, the internet, the box. While this was a hilarious prank that ended up blowing up individuals who pulled it, about circa 2007, AT&T created this cute little infographic of the internet. It's a huge map where it's pretty much a collection of systems and services that all agree to share information with each other. I mean, we go historically way, way back in the day. But effectively, you have all these systems who agree, hey, I'll send a package your way if you send them my way. Well, how are we going to do that? Oh, let's use open standards. Okay, cool. Well, way back in the early day of the internet, got my former mentor, he was a strong contributor to the Homebrew Computer Club. He told me the early old days where you'd have all these hobbyists sharing source code with each other, effectively open source. And from there, it kind of grew into this ideal where it'd be open source software, open source culture, open standards, open free beer. Now you have, free hardware and whatnot. But when you have this ideal kind of growing over time through decades, you start getting a lot of fallacies and myths and truths about it. So one of the biggest ones that I saw was no one ever said that it was secure. Sure, free, take it, but it was truly never secure. And then that's what I thought when I wrote my slide about a month ago. Then I was watching a HopeX presentation about the history of the internet, and I lied. Someone said, open source is more secure. Everyone's looking at it, and everyone's, it's locked down, yeah. And I'm like, whoa, quick rewind back, look through the title. The Internet Society president, one of the thought leader organizations for the internet said, yeah, this stuff's all right, it's secure, yeah. Just ignore DNS amplification attacks, ignore all the fundamental design flaws. And yeah, it's not secure.
Nothing. Keep going. Wow, you really need to work on your slides, man.
Right? It's just so genius, it just bleeds into people. You don't even have to see it, it just bleeds through the screens. So, I would like, if I may, to tell you a short story about the next fallacy.
Did you want yours or ours? There's champagne.
Yeah.
You choose your poison.
I will take the whiskey. Let's go for it.
We'll use our whiskey.
Well, go ahead. I'm sure everybody wants to know what's going on this slide.
Right. So this is a short story about 4 people named everybody, somebody, anybody, and nobody. Oh, good times. There was an important job to be done, and everybody was asked to do it. Everybody was sure somebody would do it. Anybody could have done it, but nobody did it.
No. Keep going. I don't want to interrupt the thing with the thing. Go ahead.
Somebody got angry that no one really did anything because it was, can anyone guess why? Everybody's job. Everybody thought that anybody could do it. Nobody realized that everybody would not do it. So we end up with it. Everybody blamed somebody when nobody did what anybody could have done. Now, when I read the story online, I'm like, wait, where have I seen this recently? Oh, that's right, the security echo chamber, blogosphere, blaming OpenSSL, like, oh, Heartbleed, oh, it was so easy to find, anybody could have found it, it was in there for years. Let's, take those 1 to 3 developers and lynch mob them. And I'm like, wait, what? 1 to 3 people, huge code base, horrendously complex, horrendously scary. If you've ever seen, was it OpenSSL Valhalla Rampage, .com, where the BSD developers are ripping it out. In fact, you should actually read a few of those commits. And no. And, further echo chamber where, hey guys, the fallacy of everybody's looking at the code or, hey guys, let's make sure there's nothing on there. No, they're really not. Or if they are, it's hit or miss.
I have a different echo chamber for you.
Yeah.
Drink, motherfucker, drink.
Yeah. Cheers.
To a new speaker.
Congratulations.
Thank you.
And actually, that's really interesting with so few words. It's like, I want to just stay now.
Yeah, right?
But I can't.
Good morning.
Good morning.
And good luck.
Thank you. Right. So, who are the type of contributors who help out with open source projects? In the lower right, you have the activist. You'll typically see this Tor and others where they want to contribute or create intellectual property to solve a particular ethical or moral or lifestyle choice. The hobbyists in the top right, they really like to scratch an itch they have. Like, oh my God, guys, I have this really cool idea in IPv6 over DNS with DNSSEC and all, Internet of Things and blah, blah, blah. You're like, okay, cool, and they'll contribute a patch set or two, or maybe they have a project, they'll launch on GitHub, have it live for a year or two, and then kind of give it up. Then you have the ones, man, that's some whiskey. Who like to do it for fun. Like, hey, I want to create this brand new programming language called LOLCat. I mean, it's not really functional, it does anything, but man, this is fun. Or hey, I want to create some Perl code that when you run it, it prints out the source code in the shape of a camel. We're like, cool, I guess, or just do it for the hell of it. And then typically you see more in the internet infrastructure open source projects is more financially motivated contributors, where they're like, this company will come in and say, hey, here's a large sum of money. Can you write this feature for us? You can contribute it, open source it, but hey, can you write it for us? And they'll get a lot of these. Or you'll have institutions who will be like, hey, I have some money here. I don't really care how you spend it. You guys are doing an amazing job. Go on. Or you'll have others that are like, hey, I really like what you're doing with this language or product. Why don't you come work for us? And you can work in our projects here, but you spend half your time work on your project. So you have these interesting incentives, but effectively, overall, these are very crucial projects that are maintained, created by a strained cadre of volunteers. Once again, it's very rare to be financially incentivized to contribute to open source projects, but they're strained and it's pretty small. So when you end up with a strained, limited resources, you have to pick your priorities. So let's pick a very overly simplistic list. You have functionality, stability, compliance, performance, usability / maintainability, and then security. Well, when I'm creating something on the internet that I want to run and set and forget and just work fairly well, functionality, nah, not so good. You're seeing projects just starting at IPv6, or some have for some time. But when I'm running these systems, I'm not looking for the latest and greatest thing. I'm looking for the most stable thing. And well, since I love bashing on compliance, let's just get that one out of here. Because, compliance is the byproduct of a good security program. But unless you're dealing with crypto or very weird arcane situations where your project may be used, such as, FIPS or in the healthcare space, nah, compliance afterthought. And I'm not sure how many of you have ever played with postfix rules or trying to configure bind, but usability / maintainability, not really an option up there. Like, that's nice, but we don't care. We're not going to maintain it. So now we're left with three, stability, performance, and security. So the fun part is, I originally thought security was kind of up there. Sure, the projects may be young. It's kind of like stealing candy from a baby if you find something in there. But once you get to a certain level, then they're financially motivated to care about security, either brand reputation or contracts dry up. But for the most part, they only really care about two things: performance and stability. The network guy, the sysadmin, the system engineer, the site reliability engineer, they just want DNS that works. That they only have to deploy 1 or 2 machines and off it goes. But ultimately, you have these very limited number of contributors who have really only so much time in the day. You can't grow time. So you end up with a lot of source code being created that's given very little attention. So it actually makes it kind of hard. So now we're going to play a game. Name this programming language. So here we have a awesome set of guys, living the life in an above ground pool, inflatable, water's there, looks like a grill, electric, hooked up to an extension cord. Whoever's saying PHP up here, someone else said that yesterday, and we'll get to that, but no. Close. But no, you're not far off. But there's a better analogy to PHP. You know, the extension cord with the wire going through, can anyone guess what it is? C, C++. I guess the easiest way to define it is from one of the top, I'd say, 20 authoritative sources on the C, C++ language, Ning. When you carry pointers around and cannot track whether they're alive and how long they are, it's going to hurt. Because the hard part is, let's ignore the hello world example, you multi-thousand lines of code, you know, thousands of files, is not only you have to worry about your application logic, like, hey, does this functionally work? But with this language, you have to start worrying about allocating memory. So you have to start doing memory management, you know, and boundary management. And then it just gets complex and you add on exceptions. And then, oh God, my brain's just hurting thinking about it. And once again, we have hobbyists, you know, just throwing in here financially, sure, you know, they write the feature or the project themselves. But unless they have a very strong secure development lifecycle, which, you know, very rare of them do, C, C++, it hurts. And well, Java, man, what can I say about Java these days? I think Charlie Miller said it best. It's not like Java got insecure all of a sudden. It's been insecure for years. The hard part is, you know, you're in this deadline development life cycle where it's like, hey, we need to get this out the door. Oh my God, we need to get this door, make investors happy. We're trying, you know, to lead the pack. And shit, we're making decisions at 4 a.m., you know, that we'll have to live with for the rest of our lives. Oh, don't worry, we'll come back to that tomorrow. You know, some of you had seen Dilbert. And really smart people are working on this. But, you know, creating a program like Java, you know, write once, run anywhere, it's really hard. And well, for the lovely fellow who loved to talk about PHP, well, it's kind of like programming with a noose around your head. Because PHP will give developers plenty of room to program and write, and before you know it, the noose is around your neck, and you're like, oh shit, fuck, and bam, it tight in strings you. And I'm not really going to talk about Go, Dart, Perl. I mean, sure, Perl's the glue of the internet, but I don't really like looking at Perl. And since, you know, this is my project and I was looking through code, nah, I'm good. But yeah, there's tons of other languages out here. Some have more secure development perspectives than others, but from what I've seen just browsing, say, what would I use to run DNS? What would I use to run X? A little bit of Python, but, you know, old school, going way back to the bricks of building the internet, you know, C, C++. You know, that's kind of what has survived over the years. So when I was starting to look at all these different projects of, there's so many out there, what do I look at? Like, what are some really big warning signs? So, you know, in the words of Bubbles, something's fucky. So I could go on about the technical side of, you know, look for really old security vulnerabilities that are still open that they haven't patched, or, you know, if they can't even do the functional, you know, feature requests from 10 years ago, you know, they're probably not even caring about security because they're doing apparently something else than writing features. But the obvious one is no strategy from the project, coding and everything, where someone will come in like, hey, this really cool itch, you know, they'll code for a year or two and then like kind of give it up, and someone will fork off the source code and then go to the other side and be like, oh yeah, this is cool. Or development-wise, you'll have all these people kind of just going here and there and implement their own memory allocation management libraries and failing to do so per se. Or also, once again, strategizing, not keeping up with the latest and greatest research, you know, that comes out of the crowd here. And yeah, it's quite interesting. And this one, next point, should be fairly obvious. So when I was, God, I think I have probably a few thousand vulnerabilities in my toolbox right now, exploits. And it's pretty sad. So like some of these are like, I really have to tell someone. So, you know, I looked on their website, looked in their source code, like how do I tell them? You know, sending emails to their RFCs, you know, Security Act and so on, no response. So I'm like, fine, I don't really have a choice. Throw it up on their GitHub, you know, issue tracker. And then one of the core developers says, John, why did you put this here? Everyone can see this. And I'm like, because I didn't know where else to put it. You know, I looked on Google, didn't find anything, looked on your website. Here's a patch for your README. I'm sorry. But unless these projects have had a large swath of issues coming their way, they don't really know how to digest them. They don't know how to handle them. So just treat them like any other defect. And second to last, complex code. I mean, this is quite technical, but if you're looking through this code and it looks really complex and you're like, I don't even know what's going on here, reality is neither does the developer. And as you can see in this chart, green is bad. Red is kind of good, but still bad. Actually, red is taint analysis, like the taint going through the source code, which you see in this project was really tainty. But yeah, just complex code. Now the one for the black hats out here, there's a lot of old installations running. So say search Shodan, give me everything for old versions of Nginx. Why? Because change is actually hard. The sysadmins, you know, security will go in there and say, hey, you need to upgrade your Apache server or your bind server because Kaminsky just, you know, said something awesome. And your DNS admins or sysadmins will be like, but you don't have to suffer any of the consequences. And you're like, yep, that's nice. Yeah, go ahead, you know, upgrade it. Yeah, so a lot of people will rarely upgrade unless they're forced to for compliance obligations or, you know, risk management. But ultimately, change is hard. So, where are we now? That is the great question. Now that we've gone through the history, let's start looking at what we're going to be doing. So, I've studied a lot of the major open source projects for web servers, hypervisors, since, you know, our audience is a bunch of security peeps, security tools, DNS, NTP servers. I don't really like Windows programming that much, so I shied away from that unless I knew, other than, you know, very few areas or, you know, critical services. A lot of people typically don't run Windows technologies to run core infrastructure services. Typically it's BSD or some variation thereof. So I guess, can anyone tell me what I think is the scariest, most vulnerable open source project out there today that everyone's using? Yeah, $50 for someone who can tell me the name of the project that is the most vulnerable, that's in use. Here's a hint. It's a mail server.
SendMail. SendMail.
Not SendMail, not Postfix. You would think Exchange, but can't make any statements to that.
Qmail.
Who said Exum? I heard that. Here you are, sir. Come on up. Exactly. Who did say that open source never made you money? So let's look at the data, shall we? Okay. So what we have here is good old Google Charts. It's kind of fun. So what we have down here is critical density. Think of critical density as, you know, every how many lines of code there'd be one, you know, critical vulnerability. What I did is kind of inverse that, saying for every line of code, you know, how likely is there to be a vulnerability in it, you know, branch the inverse. And then same with high density, high vulnerabilities, you know, not critical, not at low. Quantitatively, I could go on for hours what that means, but the reality is up and to the right is scary, down to the left is safe. Then what we have here color-wise is just the pure number of critical vulnerabilities, just overall. And then the size, just give you an idea of the size of the project overall. So not just white space and that, but the executable lines of code. So Exum, you know, 4821 has 13,000 critical vulnerabilities. What the hell? And executable lines of code, you know, sure, up and down, you could argue, but 35,000. Yeah. Let's go all the way down here to Postfix. 290 critical vulns, roughly the same code size, 37,000. Yeah, so on this chart you really can't tell because it's all relative to each other, but when we go further along you'll see overall. And XM's an outlier, almost with Bundy. So DNS, bind, God, it feels like I'm just beating on the dead horse. Yeah, so bind, let's look at a really old version of bind, bind 8. They discontinued this. It was such a horrendous project that they said, we're going to tear it all down with bind 9. We're going to start anew. Deadline development life cycle. We have to make priorities. We need to make our shareholders happy. So overall, not bad, but when you say not bad, 6,000 critical vulnerabilities, 4,000. I mean, with the newer versions per se, 2,000, I mean, it's better, but yeah, that's scary. So normally I'd have Bundy or bind 10 up here. I won't go into reasons why that was a failed project, but effectively it was split off, and there's a RIPE 68 presentation on the magical fairy dust of that project and how it was bastardized and kicked off. But effectively, it would make all of this look like an outlier to the low and left. Like, oh, it's all fine, look, it's way down to the left. No, Bundy's way up there. And also many of the other open source DNS projects that have gone off the ground recently would look far down to the left. Like, they're actually pretty solid. Even on their websites, they say, hey, we like to care about security and we do it well. Web servers, right? Top and to the right, Lighty, 98, different versions, not too bad, numbers. Out here, okay, cool. And then Nginx, you think there would be a lot, but as you can kind of see as I slowly move down here, it gets a little bit better. And then down there, solid Apache. They have a pretty secure development lifecycle. They do testing specifically for security vulnerabilities. They have a lot of infrastructure built up to handle that. So overall, I'm going to pick Apache over Lighty. Let's look at good old open source operating systems. Since I didn't have enough time nor sanity to go through the BSD stack and many other, say BEOS and other things, I pretty just picked 2 versions of Linux. And just for shits and giggles, I threw in Zen. So Zen, not that bad, 139 crits. But as we get down to Linux, the 3261 series, not that many criticals. They're pretty responsive, not to mention a little proactive. If you read any of Linus's flame war email, like, what's wrong with you, you blah, 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 not appropriate. Yeah, not so good. And then it's like, hey, let's just look at the file system and devices. And that's really where a lot of the vulnerabilities exist, is in the device drivers and file system. For the core part, sure, there's a few here and there in crypto, but not really. It's actually pretty solid. Time, something we never have enough of. Yeah, NTP dev, the current dev release, still not that bad. As we look at NTP, 426, 139, not that bad. Cronny, better. And then while OpenNTP doesn't have a lot of crits, it has a lot of highs. It only has 1 crit, but eh. So then we start looking over here at SSL, right? Everyone loves OpenSSL. So this is an old release. I don't believe it's even supported even now. And yeah, it was bad. I mean, we're looking at 4,500 criticals. And way up here, CryptoCat. And then Libre SSL. Maybe another way to kind of display this, to look at it this way. So here we have high density, critical. CryptoCat, so we have OpenSSL. This branch, not the main base they're working out of, but just imagine this as a amount of technical security debt that they have to pay off. Well, as these different teams, kind of fork the code and pay that off, Libre's doing better. Boring SSL, is 21 crits. Yubico, Keysar, Java, Yubico, GNU Crypto's doing better. Botan, Java, OpenSSL 9.8, Bitcoin. Everyone loves their Bitcoin. I don't have this data set up here, but God, when the Bitcoin 2-3 years ago, the client and the infrastructure set up, I analyzed it, and it was scary. I'm like, whoa, if someone hasn't already taken advantage of stealing everyone's wallets, then what now? And then I came back and it was cleaned up. So thank you to whoever looked at all that source code and cleaned it up. And then Crypto++. Yes, all the fun application libraries, but before we get there, let's talk about security. So OpenPGP JS, that's kind of scary. But what's also scary? A really, really old version of Snort. Like I think the current latest is like 2.9 and this is like 2.0. And then CH-rootkit, has a few crits and has some interesting privilege escalations, how you can break out. It's actually kind of scary that no one else has, or maybe they just haven't released it. Sudo has its own challenges as well. Another version of Sudo, Snort, as we get a little bit more compliant, text secure, eSAPI Java has some interesting challenges, Free Radius, Snort, Tor, has some issues, but nothing really bad. Threadfix, OpenVPN. I was expecting OpenVPN because I really want some remote code execution exploits. There are a few, but no, it's pretty solid, surprisingly. So I like to call this core libraries, but it's like what do I use on a daily basis that I would love to see exploits and vulnerabilities for. So I just picked a few. So way up in the top left, we have wget. Now I should have done libcurl and curl, but once again, didn't have enough time. But dude, wget is vulnerable. It really needs some security love and attention from either party, white hat or black hat. But libdnet, is there. Bash, not that bad, but there's a few things. And then FFmpeg. I believe there was a talk at black hat, right? And they were talking about, hey guys, watch out, there's flaws in FFmpeg. Look, we have remote code execution. Yeah, we're so awesome, it's installed everywhere. And I'm like, really? It's not that bad, at least for the stuff that I'm seeing. So yeah, there's a lot of people who think FFmpeg is really vulnerable, and if that is, then everything else, at least from my perspective, and the overall data set's way out there. So there's a lot more scarier stuff out there. So here we go. Looking at kind of all those little data sets together, far out and to the right is Exum. Now one thing about this chart that's different than the previous ones is now we're looking at this from a logarithmic perspective. Because if we were to do this linear, just kind of like, oh yeah, hey, no, that's an outlier, no. Like, no, it's legit. And I'll talk a little bit later how to go through and formalize this, but I'm like, yeah, it's bad. So yeah, it's out there. Once again, I'll be putting this all online so you can really dig through it. But OpenSSL, old version, wget's out there, CryptoCat, way down here, Linux. So once again, okay, interesting. Not as scary as you would have thought. And then, I'd be surprised. So I've been going through about 2,000 plus open source projects, hooked up to their repositories and going through it. And yeah, most of them are all right, but the critical internet infrastructure ones are scary, or the ones that are brand new are really scary. But once again, that's kind of like stealing candy from a baby. They're just trying to do Hello World. They're not trying to make Hello World secure. So with that being said, where would I be without all of the good, juicy exploits and vulnerabilities? So let's play Name This Project. So what we have here is a simple Java application, hello, I'm a string, get a request, okay, cool, doing some stuff with it, seeing if it's null, get further down below towards the bottom of line 119, okay, go do something, print this form, send that request along. Then as you get further along, kind of highlighted out.print, and I'm looking through this like, there's HTML in here, that's pretty cool. Oh shit. They're trying to search for cross-site scripting or trying to sanitize. I'm like, wait, what about there? Nope, cross-site scripting or content injection. That's not the worst thing in the world, but it's okay. You're kind of failing at it, like you're doing in many places, but apparently not here. So can anyone guess what is this project? Anyone? Bueller? Big data? Anyone? pretty close. Hadoop HDFS. They try to do well. And Hadoop is pretty scary along with Elasticsearch, but yeah, it's interesting. So one of those warning signs, to do. This code is shit. It's badly formatted. It's hard to understand. It re-implements tons of things which are already in the server core. So apparently you go along, you're like, hey, built my own little, malloc, memory application library. Like, yeah, I'm gonna get this thing. And at the very bottom, and branch line, good old 212, okay, cool, gets buffer, I'm gonna do some stuff. Yeah, I'm going through, then at the very bottom I'm gonna call my password malloc. Then the far lower left that you can barely see, effectively within that method, you're like, rad malloc, and with an int, and I go over and look, and something else you can barely see, but the source code says, this will always succeed, and yes it will. And integer overflow, cha-ching. Yeah, name that project. Free radius. Short, simple one. Yeah, this one's the typical of this project. I'm going to call this array. When I look at it dynamically, 8 bytes are my system. Okay, cool. Then down below, you stuff the array with this value, 96 bytes. So 96, 8, throws it in, blows it up out of bounds. Oh, Exum, how I love you. So what we have now are black hats. Here are some projects to go attack. It's out there, it's vulnerable, it's easy to reproduce, so on. I'll get back to you in a later. For the white hats here, make sure you apply the appropriate risk management to the third-party source code that you either include in your projects or use in your infrastructure, and use operational security best practices. And it would be worthwhile to have yourself or someone that you highly trust to go through the source code as well, and make sure everything's secure. So yeah, you have many people looking for these. I was amazed that I was finding these, just pure number. Like, how? Like, why am I not seeing full disclosure exploding? Why am I not seeing these mailing lists? Why are all these entities such as the NSA and others such, VUPIN and others, just, am I the only one just keeping this in my toolbox? Like, what's going on here? And I'm not really doing anything special, and neither do you have to as well. So whether or not you want to do this for street cred, to get a job, or say, hey, look at my name, I'm a narcissistic vulnerability pimp. Or maybe you just want to sign off as net dev and send an email to full disclosure saying, hey guys, look at this cool exploit, hack the planet. Or maybe you just want to do it for the lulz, like, yeah, watch you assert just explode, quick send, out full disclosure, days, like, guys, here's remote code exploits for Linux through the terminal. And they'll be like, Or very much like myself, you just want to have security grenades in your toolbox. That's why we never called for engagement or anything. You're like, yeah, worst case, I'll just throw an OID down and check, yay, give me my money. But what you could also do is go the more white hat route. Bug bounty programs such as HackerOne and Bugcrowd and others will offer you some small sum of money, depending really on the person who's paying on your behalf. Or you kind of go to the gray market where the ethical and legal, moral boundaries aren't so clear. You could probably get 10x for that. Or you sell it just straight underground, and get 100 to 1,000x. But it really depends what is your incentive. Because once you figure out your incentive, really determines how much time and resources you're going to build into this. So my typical stack was using Git or tying into the project's version control software such that I didn't have to watch all the time, like just have my automation kick off. Oh look, someone did something at 2 a.m. I didn't have to wake up and push buttons, it just kicked off. I was using Amazon Web Services, but a few hundred instances. You don't really have to, really depends on what scale you want to go. You could have it run on a moderately powered laptop. Obviously, you don't need the latest and greatest graphics, but you need a decent solid state drive and memory. Just like Neo said, we need guns. Well, you'll need memory just to handle all of this. And then I use Jenkins to do the orchestration and building and kind of tracking everything, which projects are scary, which ones are not. Hey, John, we need you to pay attention. But ultimately, I was doing two things, static and dynamic analysis, and then blending the two together. So on the static side, you could use for C++ languages, Clang, Ruby, good old Brakeman, find bugs, or you could use a proprietary software such as Veracode and Fortify. I mean, there's tons of these tools out here. You just have to understand the limitations of each. But static has its faults. It won't find everything. It'll say, yeah, I think there's something here, but I'm not really sure. That's where you have to get the dynamic side as well. So instrument your application with Valgrind, dtrace, OilyDB, and then really hit it with fuzzing such that you get your code coverage as well. Such that when you get all three together, you're like, oh wait, I know how to reproduce this. Hello, exploit. But also, I kind of see where I didn't hit, and you kind of look at it real time. And if you don't want to do this, there's a lot of new infrastructure components oriented towards open source projects, but they still haven't made you authentify yourself as, hey, I'm from Bind, ISC. So you just say, yeah, throw Bind in there, and they'll just break it and give you all the vulnerabilities. So thank you. Swamp is, a great tool like that. But ultimately, you're going to end up with all these vulnerabilities. You need some assurance such that when I come up here in front of you, I'm not just blowing a bunch of hot air in your face. So look at the Natural Vulnerability Database, all these CVEs, and work backwards, rev the code to then, and then run all your automation on it and be like, hey, what's going on here? I didn't find it, and then find out why, learn, and then keep on tuning until you get there. But the problem with that is you're going to have a lot of wheat and chaff. And you need to separate the two. So since I love programming in R, great for working with data sets and everything, it's pretty easy to get a very black and white. Sure, there'll be an area of gray, but that's where your manual side comes in as you're manually verifying the issues and also source code in addition to static and dynamic. But I know math and computer science is hard. So here's some research from some Stanford researchers. They're like, hey, you have all these vulnerability data sets from distinct sources. Here's how you pull them all together. Okay. So without going into the gibberish, math there in the lower left of the screen, effectively, you have all these data sets. How confident are you? Okay, cool. Does some cool stuff and then pulls them all together. Nice. Well, now I need to rank them. So, I can be like, haha, I have a higher rank than you. Look at my exploit. They also produced a ranking algorithm. So, as you can imagine, the network here isn't that safe, and I don't really trust right now anything that's electronic in Vegas. So when I get back home, I'll upload all of the source code, all of the findings, should I say summarize, not being like, hey guys, but if you look at some of my previous work on securesql.info, you'll see where I ripped apart OpenSSL, Node, there's tons of stuff there. But ultimately, the website for this is going to be hacktheplanet.ninja.index.html. So just go ahead and head here. Here's all your fun stuff. Ooh, yes, you have to have all the fun little fonts, that. But effectively, that's it. So I'd like to thank everyone for coming. But wait, one more thing. So you guys are keeping calm and you're hiding in the box that is the internet now. I've always wanted to see a remote code execution or exploit for Notepad. Right, like, come on, where is it? Like, I've been waiting. Realistically, you'll never see a remote code execution, but like, come on, privilege escalation, anything? No. Well, I'm like, wait, what would be the equivalent in Linux BSD land? Wait, Vim. Yeah, Vim, Pico, Nano. Then I'm like, wait, I'm a Vim user. I love it. Yeah, let's hate on some Emacs. So here we have Emacs. I won't say too much because I haven't announced this at all, but line, 2788, you have this character array. It's about 4,000 bytes in size. Then further down along in fscanf, very large number stuffed in there. So yeah, nice try, thanks, but no thanks. I like Vim, I'll stay. But thank you for coming, that's all.